Good evening, guys. My name is Amarnath. Today, I have come forward to give you all a very good demonstration on the Spark transformations with RDDs. The background of this video is basically the Spark transformations are very confusing, and most of the people are quite new to the key value pairs, tuples, and elements, and the way they are getting transformed with different transformations and functions. My approach today would be I have written a very detailed logical implementation notes for each transformations. So the transformations which we are going to discuss today is reduce by key, combine by key, aggregate by key, and group by key. uh, when I was a beginner for Spark, when I was working on the data sets, RDDs, tuples, and elements, I used to get confused so often, and I have to go ahead and read the articles again and again to understand how it works. On top of it, it seems to be understanding. It seems to be I got the things correctly, and when I go and start working on implementing those transformations, I clearly saw there's a gap. In such cases, I used to call my technical gurus, discuss with them, and come back and refer article and like that. It happened 2 to 3 times, and then I finally made my mind, no, this is not going to work out. Let me clearly document how each and every transformation works, and let me be very clear so that I need not have to come back again and check. So this document which I have prepared for myself has given me a very good confidence that I can work on any transformations in Spark now. Having gained that knowledge, I thought, okay, why not let me share this knowledge to everyone, so that if there is any new starter, he or she will be able to understand and take things as the way they come. So that's what the background of my video today. So I hope you'll enjoy this. I will try to finish it off in 1 hour, 30 minutes for theory and 30 minutes for practical. All the transformations, all the four transformations which I'm going to show you now logically in the 30 minutes will be implemented practically on the CloudWork Kickstart VM. I have everything ready in the background, so let's start it now. So the first transformation I want to discuss with you is reduce by key. As the name itself says, boss, filter the data based on the key and reduce them with and give me the result. So we are going to use the same data sets for all the four transformations. So I want you all to make one thing printed in your mind is Spark works on a cluster. Spark works on a resilient distribution data sets, which can be called as, oh, I'm sorry for that, which can be termed as key value pairs, tuples, and elements. Don't worry about it. I'll explain you what is a key value pair, I'll explain you what is a tuple, and I'll explain you what is an element as a whole. So there are different terminologies that comes in our 1 hour of journey, and I'll make sure you understand each and every terminology very clearly, and I'll implement that logically as well. So the first things first. So let's understand a key value pairs first. So reduce by key works on data sets, and it only works on one data set. Other transformations can work on two different data sets. You can join them. Once you join them, you get a key and a value, or you get a key and a combination of values like tuples, and you get an element. You can implement transformation on those RDDs or data sets. In here, reduce by key only works with one RDD, or it can say one data set. So each RDD can be implemented or partitioned across the data nodes. As you know, the block replication or replication topology, the partitions is very important in the Spark cluster. So please be informed, any data set or any RDD will be distributed across the cluster with the partitions. So for example, I will go ahead with my one partition, which is called this one. If you see this one, partition one here, I'm going to take this one as my input first. So I'll complete this partition implementation for reduce by key, and I'll come to the second one, and we'll go to third one, and we'll see how it's implemented and how it's going to combine all the partitions and make the work easy for you. Okay, so partition is just that your data is split across data nodes. Perfect. And if you see here, k1 is the key, and 1 comma 2, don't think it as a value. let's consider it as a tuple now. If you have only one value, if you have only one, it can be a value. If k comma v, k is a key and v is a value, if you have only one integer, or if you have one value, it is called as a value. But if you have one or more values, then it is categorized as a tuple. So in this example, I'm explaining you, I'm taking k1 as my key and 1 comma 2 as a tuple. So 1 comma 2 enter value is my tuple here. So I hope this is clear for you. So some partitions can contain multiple keys. The reason why I have written this statement here is, for example, as I told, reduce by key works on partition by partition. So partition work will be done parallelly, but the iteration will be done sequentially, so don't get confused on that part. Okay, so some partitions can have multiple repeated keys, and some partitions may not have multiple repeated keys. It works on the replication topology or the rack topology or whatever in the background, so don't worry about that. But make sure, don't get confused if you don't have the repeated key in same partition. It may have, it may not have. So the dataset partitioned across the nodes in the Hadoop cluster are represented in a single RDD. So for example, this partition 1, this partition 2, this partition 3 is completely one dataset, but it is distributed across the partitions. So that's what my explanation here is. So for example, if you wanted to implement reduce by key, I'll give you an example of counting 1 to 5. Okay, the way how it works is, 1 plus 2 is 3. Okay, 3 plus 3 is 6, and 6 plus 4 is 10, and 10 plus 5 is 15. First time what I'm asking is, I'm just asking you to count 1 plus 2, which output is 3, and I have it 3 here. And I'll ask it to count 3 plus 3, which is 6, and after I'll ask it to count 6 plus 4, which is 10, and later I'll ask it to count 10 plus 5, which is 15. This is the base, this is the core logic under which reduce by key works. It just reduces the value based on key. So for example, if you have Amarnath repeated 10 times, it goes and assigns 1 1 1 1 1 Amarnath 10 times in the first phase, and in the second phase it goes and counts that once, 1 2 3 4, how many times the one has occurred, that's the value, that's the final value. So this is how the core basic functionality of your reduce by key works. Now we need to understand the syntax of reduce by key and how we can implement the syntax to understand the logic. So guys, the complete syntax is here. Data rdd dot reduce by key. Data rdd is nothing but the partitioned data what I have shown you there. So here, data rdd reduced by key x comma 1, x underscore 1 plus y underscore 1, comma x underscore 2 plus y underscore 2. So don't get confused what is x underscore 1 and y underscore 1, x underscore 2 and y underscore 2. As I have told you here, this is my tuple. Tuple are always accessed with underscore 1s and underscore 2. This is my underscore 1 here, and this is my underscore 2 here. Okay, so coming back here, if you see, as I have given it, x comma y is my initial initialization. In that initialization, my dear function, go and take the first value of x and count it with first value of y. In the same way, go and take the second value of x and count it with the second value of y. Don't I'm going to break the logic here. This is x, this is y. The first part of x, if you see here, first part of x is 1 comma 1, and I'm going to count the first part of x with first part of y, which is 1 plus 1 2. In the same way, I'm going to count second part of x with second part of y, which is 2 plus 1, 2 plus 7, I'm sorry, that's 7, so it's 9. So 1 plus 1 equal to 2, 2 plus 7 equal to 9. So here most of the people get confused, like x, even I'm confused in the first stage. So I want this to be very clear, everyone. X comma Y are not the key value pairs. X comma Y are just the initializations for your Spark to understand your data set. So here you are just initializing X comma Y as a parameter or as a function to your parameter, and it is you are asking it, you are asking Spark to take the first value of X and count it with first value of Y. Go and take the second value of X and count it with second value of Y. In the tuple, the first of X plus first of Y, second of X plus second of Y. In that way you got 2 comma 9. Okay, now similarly you will take the second value of X and second value of Y, apply summation. Okay, and I have written it very clearly. This is an iterative algorithm implemented one by one. So it has completed in the partition 1, and then we'll go to partition 2. If you go to partition 2 here, you have got 2 comma 9 in the first key value, I mean in the first partition. And now when it goes to second partition, if you see here, uh, this is partition 1, this is partition 2. Did I get k1 anywhere else here? No. And I have k comma 1 here. See, one important thing I wanted to highlight here is, if it is repeated, if it is repeated n number of times, that many times it makes an entry, and that entries are counted at the last. So first I'm completed with this two, which is k1 1 comma 2, k1 1 comma 7. This output is nothing but my k1 2 comma 9. Okay, and next, as the same key is completed, it scans through and goes to next key, which is repeated, called k1 2 comma 6. In k1 2 comma 6, what it does is, again, this is X comma Y. So go to first value of X. Guys, once again, this is a key and this is a tuple. Tuples are represented with underscore 1. My underscore 1 is this one, underscore 2 is this one. When I say X of underscore 1, which is this one, when I say X of underscore 2, this is this one. When I say Y of underscore 1, the value is this one. When I say Y of underscore 2, the value is this one. So the first part is completed, and second part, it counts this one. 2 plus 2 is 4, and 9 plus 6 is 15. So it gives the final result 4 comma 15. So this way it has completed the partition 1. When you go to partition 2 here, k3 k4 k5 k3 k4, what is repeated here? K3 is repeated here, right? K3 1 comma 4, K3 1 comma 9. Let's come back. K3, 1 minute, 1 minute. I don't want to confuse you guys. Let me come back. Okay. So partition 1, you have got 4 comma 15, which is perfect. And if you see K2, partition 2, sorry, in the partition 2, what is repeated here? You have got 1 comma 4 and 1 comma 9. So it is 1 plus 1 and 4 plus 9. Okay, in that way it gives the result as k3 1 plus 1 and 4 plus 9. Perfect. 3 comma 19. Okay, it is 3 comma k2. 1 minute, guys, I wanted to k2, yeah. K1 is complete. I'm still talking to partition 1. I'm sorry, I don't want to go to partition 2 until unless I complete all the all the keys in partition 1. So K1 is completed here. Let's go to K2. If you see K2 here, this is my complete key is X, and the next one is Y. 1 plus 2 is 3, and 8 plus 9 is 17. Let's see. Did you get it? It's 3 comma 17. Now let's go to next thing. So K2 is repeated, we have sorted out. And next one is K7. What happened to K7? K7 is not repeated in the partition 1. So this is K7, this is not 1. That's my bad handwriting, bear with me. This is not 7, this is not 1, this is 7. So K7 is 1 comma 8. In this way, it has scanned through the partition 1 and filtered the data based on key. So K1 is sorted, K2 is sorted, K7 is sorted. This is for one partition. It does the same function, it does the same operation, same implementation logically in the partition 2. When you talk about partition 2, you have K3 1 comma 4, you have K3 1 comma 9. So 1 plus 1 is 2 and 4 plus 9 is 13, right? K3, K3, 1 plus 1, 2, 4 plus 9, 13. I'm talking about K3 here. So K3 is, I'm sorry, this is mistake. This is not 19 actually. 9 plus 4 is 13. Sorry guys, I can, this is just a mistake. Bear with me, forgive me for that. And let's see K4 now. If you see K4, 2 comma 7 and 1 comma 4, 2 plus 1 3 and 7 plus 4 is 11. Okay, so you have got 3 comma 11, which is perfect. And what happened to the other one? K5, it is only one time, there's no, it's not repeated, so it has given K5 1 comma 6, which is perfect. Now let's go to partition 3. This is my partition 3. In partition 3 you have K6 repeated, so first value of x plus first value of y and second value of x plus second value of y. 1 plus 1 is 2, 8 plus 4 is 12. So K6 you have 2 comma 12. So K6 I got 2 comma 12. Awesome. Let me go back. So do I have anything repeated here? I think K9 is repeated. K9, K9. So first value of x plus first value of y, second value of x plus second value of y, which is 1 plus 1 2, 7 plus 7 14. So my K9 will be 2 comma 14, right? So I have got 2 comma 14. Now this is locally on each partition. It's responsibility of Spark or for the reduce by key function to go ahead and give these values to the driver, and from there you can get it. So final output will be your K1 has got this value, your K2 has got this value, your K3 this much, K4 this much, K5 this much, K6 this much, K7 this much, K8 this much. To understand, to make it very clear, you have got this much of unshuffled data, and your reduce by key has shuffled it, or it has reduced your data based on the key and gave you the output. This is the first part of our reduce by key. Hope I made it as much as clear as possible. Simple guys. To make things short, first understand the syntax and see how it is logically implemented. I'm not asking you to by heart it. I'm asking you to understand the logic. So I have defined the value as, I have defined the initialization as x comma y, and I'm telling it, my dear reduce by key, your syntax is first value of x plus first value of y and second value of x plus second value of y. When I say value, don't get confused. Key value pairs are different, tuples are different, and tuples are represented by underscore 1 and underscore 2. Underscore 1 will be the first element within the bracket, and the second element will be underscore 2 will be the second element within the bracket. Okay, and things with tuples will be more clear in next subsequent sessions, because there are more complex transformations you are going to use in that will be very easy for you. Hope the reduce by key is clear for everyone. So now I'll jump on to group by key. Group by key, the way we have used the RDD, here we are using a different way. I'm giving values as words, and I know it's an array, which is 1 2 2 Hadoop Hadoop Hadoop. And when I ask parallelize, first thing, val words is you are defining a variable and you are assigning an array with the definition of it. And when I'm asking to generate pair RDD, which means SA is Spark context, and I'm asking to parallelize the words is nothing but, dear Spark, the array of strings or array of data what I have given it to you, can you please kindly distribute it across the Spark cluster, across the nodes with partitions? It done it. And then you are applying a map function on top of it, and your map function For each word you are asking word comma 1. So what it simply does is your 1 time, 2 1 time, 2 1 time, Hadoop 1 time, Hadoop 1 time, Hadoop 1 time. So the first operation is done. You are not doing a word count here. You are just assigning a number 1 for each array based on the occurrence of it. Okay. So the val words is an array element. Parallelize distributes the data across the cluster. Map function picks up each element in the list and generates the result based on the functions defined. Here we have defined the function just to assign 1 to each word. If I change this function to count my words and give me the total count, it will do it. That's a different story altogether. Okay. So the output will be 1 has come 1 time, 2 has come 1 time, 2 has come 1 time, Hadoop 1 time, Hadoop 1 time, Hadoop 1 time. So for each element in the list, it will generate a tuple. Okay. Got it. And now group by key, wherever the same key is available, group it. So okay, we have seen the reduce by key. Now we are grouping it based on the key. 1 2, I have 2 here, and so 1 will be 1, 2 will be the 1 comma 1, Hadoop 3 times, so 1 1 1 3 times. And now uh, group by key just groups the data, and once the grouping is done, on top of it you will apply the reduce by key. I want everybody to understand this. Group by key is not doing any kind of uh, transformation. Group group by key is just grouping the data, and once the data is grouped, on top of it you are going to implement the reduce by key. So I'm explaining word count with reduce, generate pair, which is nothing but the value what I got here. I'm using a reduce by key, and I'm giving this definition to it and asking it to collect. So don't get confused, why the hell is this guy using underscore plus underscore? It's nothing but this performs the summation operation on all the values in the group, not across the group, within the same group. For example, this is this is my this one is called my what I can say is this one is my group. As I've asked it to group by key. uh, Hadoop is one key, 1 is one key, 2 is one key. Underscore plus underscore means underscore plus underscore means whatever the values you have there, count them. So 1 plus 1 plus 1 is 3, it's only 1, it's 1 plus 1 is 2. Okay. Now if you see, you have got Hadoop 3 times, you have got 1 1 time, you have got 2 2 times. So Hadoop 3 1 2, that's what it is. Hope you understood the difference between reduce by key and group by key. Group by key is just grouping your data set based on the key. Okay, it's not doing any summation. On top of the grouped data, you are using reduce by key function here. And at the last at the end of this presentation, I'm going to tell you also the difference between each of the transformation and each of the function, the way how they works. Clear? Let's go on to the next part. Okay, so as we have understood the first way of group by key, let's go and understand the second way of group by key. As said, group by key just groups the data, and on top of it you apply the functions. Very simple, very understandable. Okay, now word with grouping. Generate pair RDD. Generate pair RDD is nothing but this one, on which you have asked the Hadoop cluster to parallelize the data, distribute it across the nodes, and then assign a number 1 to each word. This is your generate pair RDD. Generate pair RDD basically means for each key, get a value of 1, which is a key value. Okay. Now I'm going to run my transformation on top of this one for this functionality. Okay, if you see here, I'm using the syntax group by key. I'm asking a map function, which is a tuple. I'm asking the first value of tuple minus second value of tuple comma summation. Here t means tuple, as I have already told you. Key comma v is a key value pair, and if you have key comma number of, if you have if you have one or more values, then that is called a tuple. And the way you represent tuple is, tuple will be represented with underscore 1. Okay, so when I say Hadoop 1 comma 1 comma 1 and 1 comma 1, t comma minus 1 is Hadoop, right? So t comma minus 2 is 1. Okay, and t you are asking the map function to do the summation. So Hadoop is my tuple, and t Hadoop is my tuple. I'm asking to sum all the values. It is 3. Is it clear? I think I'm, even myself, I have not explained it very clearly. I could sense that. Let me rethink. Okay. Okay, guys. T is a tuple. Okay, this one is my tuple here. Hadoop is a tuple. 1 is a tuple. 2 is a tuple. When I say t comma minus 1, t comma minus 2, it's not minus 1, it's underscore 1. T dot underscore 1, t dot underscore 2, t dot underscore 1 will be 1. Okay, t dot, oh, sorry, t t dot underscore 1 is Hadoop, and t dot underscore 2 is 111. So I'm asking you to count how many ones you have. So that's done. And your t1 is 1, and you are asking t2 to sum up. T2 is nothing but this value, which is 1 comma 1. 1 plus 1 is 2, and this is t1 and this is t2. There's nothing to count here, it will just give you 1. Okay, so don't get confused. I'll explain this once again. This is your tuple t1, this is your tuple t2. Okay, so t1 comma means Hadoop comma t dot underscore 2 comma sum. Whatever you have in this closed bracket, or whatever the parenthesis it is in the bracket, count them all. So it is counting. T dot underscore 2 dot sum is whatever the collection you have in the bracket, count them up and give me the result. That's what it is. Okay, so now we have seen reduce by key, group by key. Group by key just groups based on the keys you have, and on top of it you can apply reduce by key. We have implemented reduce by key in two ways. The first way, we have just used underscore plus underscore, asking it to count all the values it has. And the second time, you have represented with tuples, and you have asked the tuple 1 as your key, and to count the values as t dot minus 2. Clear? So simple differences between reduce by key and group by key. Reduce by key and group by key give same results, which we have just seen. It just gives one, for example, number of times the word repeated, it gives ones to that, and in the next phase it goes and counts all the ones, and after that, based on the partitions, it collects all the data from partitions and gives you the final result. Reduce by key works better. Group by key first shuffles and then aggregates. I'm going to show the knowledge base article on this one. 1 minute. See guys, if you see here, reduce by key, the basic difference is, this is node 1, node 2, node 3, node 4, node 5. So, or you can assume it any way you want. If you see here, a1 b1 a1 a comma 1 b comma 1 as a key value pairs are given as is. And if you see here, it has already done the summation of a2 and b2. And if you see here, it already has done the shuffling of all the ones as 3 and all the b's as 3, which is perfect. And if you see here, it has again counted one a, it has already reduced all the a's, 1 plus 2 plus 3, which is 6, and all the b's, which is 1 plus 2 plus 3, 6. If you understand one thing here, locally it has done a little work, which means it understood uh, I have got once, let me count those words and get my data shuffled properly. as the most of the transformations are done on the local node itself, on the local partition itself, so you'll have very less on the reducer end. So the map face will have most of the work already done. That is the reason why people say reduce by key is the best. Okay, so to explain you more clearly, see here, group by key. Group by key, what it does is it has done nothing at map faces. It just it just has the values the way it is. Everything has to be done at the reduce phase. Reduce phase is like, at the result, at the after the completion of, before the completion of your transformation. So in this way, all the a1s b1s a1s a1 b1s in this partition, this partition, all the data must be traveled across the network into this node and also this node for the shuffling to happen at this space. That is the difference here, and that's what I have written. The first shuffles and then aggregates. This involves huge traffic recurring a performance issue. The reason why I say performance issue is it's just A's and B's here, which is fine. But if you are processing or transforming a huge TBs and TBs of data set, how complicated would that be? So considering that in mind, it's always best practice to avoid group by key as much as possible. Think twice and thrice when you think of using group by key function. Refer to Databricks best practice documentation. So this is the documentation that explains. I can share this with you. It's already available online as well. Nothing to worry about it. So this is the example I have just shown you. If you see here, this is the example I have shown you. Uh, First, we have implemented reduce by key in this way, and then we have implemented group by key, and after having group by key, I have implemented the map function on it. So this guy, what he's doing here is, without implementing group by key here, what result I have got with reduce by key and what result I got after group by key with map function is same. Got it? Is that okay? Is that clear, guys? Once again, I wanted to repeat this. Reduce by key and group by key gives the same results. Reduce by key is just you are summing all the ones it collected at the map face, whereas in group by key it already grouped those values, and on top of it you're applying a map function using tuple terminology or tuple initialization to get the result. The reason why group by key is little risky is it has got to do so much of network data transfer, which leads to a performance issue. Hope I made things clear over here. So let's move on to fold by key. So fold by key is other important confusing logical master here. So I'll try to make it as easy as possible. So the first one is fold example. Let's understand the syntax. Fc.parallelize. Parallelize nothing but you are asking Hadoop or Spark to go ahead and distribute this data across the data nodes as per the partitions, and you have 1 to 10 as the initialization in the parallelize function, and you are starting the fold from 0, and you are initializing an accumulator and an element. You wanted to count the accumulator and the element. So now you will ask me, where the hell and what do you mean by accumulator and what do you mean by element? I'm going to explain that for you. So the way we have used the 1 2 3 4 5 and summing 1 2 3 4 for example, let's use the same thing here. Okay, if you see here, for the fold operation start with the summation, it needs an initial value to start, which is initialized as 0. So for example, guys, 0 plus 1 is 1, 0 plus 10 is 10, 0 plus 9 is 9, 0 plus 7 is 7. So if you start with 0 for the summation, it does not manipulate your execution, or it will not manipulate your end results. So for that reason, the syntax says initialize the summation with 0. So that's what I'm doing here. So 0 is my initialization summation, and after coming here, Using 0, which won't impact your correct results. That's what I have just explained you. So if you take 1 2 3 4 5 as my correct data set, when you start fold of 0, it will automatically start with using 0. So 0 plus 1 is 1. Okay, so understand one thing here. 0 plus 1, this is an accumulator, this is an element which give a new accumulator. Okay, and this 1 is an accumulator, and this 2 is an element which gives a new accumulator called 3, and this 3 is a new accumulator which counts with the element 3, which gives a new accumulator 6, and this new 6 accumulator gets counted with 4 element which gives a new accumulator 10, and this new 10 accumulator counts with the new element 5 which gives the 15 as the last accumulator. Okay, so this is what it is: accumulator and element. That's what I told you. Key value pairs are different, tuples are different, elements are different. When you say elements, elements is like you, as you have initialized. For example, simple, you have 1 2 3 4 5. Okay, when you have 1 2 3 4 5, you are starting with 0, which is initialization value as accumulator, and when this accumulator is adding to your data set, there is an new value coming up, that is nothing but an element. So you're counting your accumulator and an element. I'll explain this very clearly. 0 is an accumulator. Ideally, what does the English term accumulator means? Accumulator just accumulates the results. Simple. It just stores, or it's just nothing but stores the result. So 0 plus 1 is 1. So this one is a new accumulator, and 2 is the element. Accumulator plus element gives me a new accumulator. 1 plus 2 is 3. Fantastic. This 3 is a new accumulator which should be counted with an element, which is nothing but 3 plus 3 6, gives me a new accumulator. My function is nothing but accumulator plus element, which is 6 plus 4 10, which gives me an accumulator, and this accumulator should count to the element, which is 15. Simple as it is. That's the reason why I have clearly mentioned 1 2 3 4 5 are elements, boss. Okay, understanding the accumulators and elements is very important. If you don't understand this one, aggregate by key and the combine by key will screw you up very badly, as it happened to me. I have to call my technical guru and ask each and every time. I have watched 3 times, 4 times. I've read 3 times. It's not understanding. It's is it my understanding capability issue or something like that? But it's just you need to just think logically and understand the interpretations of it. So if you understood this accumulator and element value very clearly, your combine by key and aggregate by key will also be a cakewalk. Trust me, take my word. So that's all it is. So now you have completed your accumulator and value. Okay, next thing is, for example, let's do this. 0 plus 1 is 1. This is an accumulator. The first pass you get 1, and when you go here, 1 plus 2 is 3, you get 3, and third pass is 3 plus 3 is 6, and fourth pass is 10. Okay, so 0 is an initial accumulator. Got it? So we are at fourth page. Let's jump into fifth page. We have finished fifth page, sorry, sixth page. Okay, now in tuples, the first value will be key and the second value will in the tuples is a value. Okay, sorry, in tuples, first value will be the key and the second is value. Second is the value means, I mean to say, element of values. And understand the difference between tuple versus element, which will make your journey easier. Okay, and the second approach for fold by key, here I'm trying to count elements in the list. When I'm trying to count the elements in list, one basic difference you need to understand is, here you have asked your fold function to go and count the accumulator and element. It gave you the final result. I agree. But here I am asking it to count plus one. Okay. In the same function, we are trying to count the elements in the list. So the first is sc.parallelize, understand the syntax and apply the logic. Sc.parallelize, parallel is nothing but you are asking Spark to distribute the data set or the elements across the nodes based on the partitions, and you are initializing the value with 0, and you have an accumulator, you have an element, and you are asking your accumulator to add 1. So 0 1 2, so you don't have 0 in your element or data set, you have initialized it in the parallelize function or the fold function. So 0 plus 1 is 1, and your accumulator is 0. Okay, 0 plus 1 is 1, and what happens, 1 is the new accumulator, 1 plus 1 is 2, 2 is the new accumulator, 2 plus 1 is 3, and 3 is the new accumulator, 3 plus 1 is 4, 4 plus 1 is 5. In that way it keeps summing up. Okay, so fold by key function is applied on each key individually. For example, if you see k1 1 to 10, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 is 55. The way how it works is accumulator, element, on top of it accumulator plus 1. Okay, your accumulator will be initially 0, and you are just counting 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. In that way you get the last sum as 55. If you say key 2, k2 as a key value, key as a 2, and 1 to 5 as elements, you get 15, and you get k3 1 to 7 is 28. So fold by key requires a dummy value, the similar way how we have used the 0 as an accumulator. Okay, simple. So the perfect use case will be find maximum score by department. Okay guys, this is very important. If you understand this one, I think we can wrap up the session, we can close off the session. That's the importance of it. Okay, so don't get confused if I'm going too fast. I don't have anybody online also to tell me if I'm going fast, sorry for that. So what happens is, here you have initialized 0 when you are doing the count of elements, and here also you have initialized 0 just to do the summation. Summation is nothing but the total sum, I mean total sum, and the count elements is number of times the element, number of times it has occurred. Okay, counting elements in the list, sorry. So the next thing is finding the maximum score by department. uh, this example, to be honest with you, to find the maximum score you always need a dummy value and compare a dummy value. For example, if I say I have a friend called Janardhan, and if Janardhan has got 100 marks and if I got 95 marks, obviously 100 is greater than 95, so your result will be 100 emitted out. Okay, but in the fold function it should, it's okay if you start with, if you compare with Janardhan and Amarnath, 100 and 95, 100 is highest, it will give. But how does the Spark understand from which point should I start comparing the marks of each student? That is the reason why you start with the dummy value, dummy comma 0 comma 0. When you say dummy 0 comma 0 comma 0, it's nothing but key, your accumulator, and your element. Okay, sometimes you also need to have define, you also have to define the data type of it, which I'll explain in the next functions, that is aggregate by key and combine by key. Okay, so if you see here, understand the syntax, apply the logic. While maximum department equal to employee RDD, which is nothing but this one, this is my employee RDD. Okay, I have it here, employee RDD, and I'm applying a fold by key function. Guys, try to understand, fold by key function is different, fold is different. Okay, initially I have explained fold here, which is nothing but the how logic works to initialize the accumulator and value. Here I'm explaining you fold by key, which is something similar to your reduce by key and group by key, but the logic is little different. Okay, so in fold by key you have initialized a dummy comma 0 comma 0, and you have an accumulator, you have an element, and you are telling if my accumulator, if second part of my accumulator is greater than the second part of element, show me accumulator, or else show me element, or give me element. Let us implement this one. So this is my list, and this is my sc.make rdd. I have made rdd. This is perfect. And the first part is, if you see here, this is my accumulator, which is which is dummy 0 comma 0, and this is my element. As I have been telling you, accumulators are represented with underscore 1 and underscore 2. So this will be your underscore 1, this will be underscore 2, this will be underscore 1, this will be underscore 2. Okay, so what are you giving, what are you giving in the syntax? You are telling, dear Spark, the accumulators underscore 2 if greater than element underscore 2. Accumulator underscore 2 is which one? This one. And elements underscore 2 is which one? This one. Is 0 greater than 1000? No, it's not. So it is written in element, which is 1000. Perfect. So now this Amit comma 1000 will be your new accumulator. As I have told you very clearly here, this is 0 comma 1 will be 1, which is new accumulator. This accumulator gets summed up with the element, gives the new accumulator again. This concept will be same across, so don't get confused yourself. The new value which comes up will be the new accumulator. So this is the accumulator, and this is the accumulator, this is the element. When I say accumulator, accumulator of accumulate underscore 2, which is 1000, compare it with element underscore 2. Is 1000 greater than 1200? No. If it is no, then give me element. So it has given the element here, which is perfect. This one is for computer science partition. Perfect. Now let's go and have a look at EC partition. In the EC partition also, I have to do the same thing. Okay, I have to initialize with the dummy value, which is dummy comma 0 comma 0. Okay, makes sense. And now accumulator minus 2 greater than element minus 2. Is 0 greater than 1500? No. So it will give element here, which is Rakesh comma 1500. Now your Rakesh comma 1500 is the new accumulator, and this accumulator second value, or your accumulators underscore 2 will be compared with your elements underscore 2, and then gives you the desired result. So if is 1500 greater than 1200? Obviously. So it has given the accumulator here. So what is the final result for me? In computer science, Rahul with 1200 is a good percentage, or Rahul with 1200 is a maximum score, and in the easy, Rakesh with 1500 is a maximum score. That's what it is. So I'll recap: reduce by key, group by key, fold, fold by key. So reduce by key is very simple. It reduces the value based on the key. So for each key, based on the number of time it has occurred, excuse me, it goes and applies a value 1 to it. So in the next phase, it goes and counts all those ones and gives you the result. That is reduce by key. And next one is group by key. Group by key is nothing but it is grouping the values. On top of it, you're applying reduce by key the way you want. One example is you are asking tuple of tuple underscore 1 comma tuple underscore 2 and sum. Tuple of underscore 1 will be always your key, and the next one will be your values. It will count all the values. So once again, my sincere and honest request, don't get confused between key and value. Key val Don't get confused between key and value pairs, tuples and elements. Okay, we have revised group by key, reduce by key, fold. So fold function is nothing but we are initializing the fold function with a 0, accumulator and value. And in the first place, you will ask to count accumulator and value, and then you will ask to count accumulator plus sorry, accumulator plus element, and you will ask accumulator plus 1. Accumulator plus 1 is just to count the elements, and if you are asking accumulator plus element, it keeps summing up the iteration. Okay, hope I'm clear till this point. Now let's go to the second one, or seventh one, eighth one, which is combined by key. This is more important, and the combined by key is like very highly used transformation. So combined by key uses four important parameters. First one is creating a combiner, second one is merging value, third one is merge combiner, and fourth one is summing the partition. Create combiner means it's very simple. For example, if you have a key, and if you're talking about part in this context, in the combined by key context, let's talk partition by partition. So you have one partition, you have one key. When your combined by key function is reading a key for the first time, it creates a partition. Okay, in the same partition, if the same key is repeated second time, then the combined value of the first partition will be taken as a reference and counted the second one. I know if I say theoretically it will be kind of confusing, so that's the reason I have written the notes here. Let me go ahead and explain that. Okay, so here we are trying to calculate the average. While calculating the average, we'll implement the step by step. So you have a node 1, you have a node 2, you have a node 3. In the node 1 you have partition 1, you have partition 2, you have partition 3. So in your first partition you have key and value pairs. In second partition also you have key and value pairs. In third you have key and value pairs. Okay, so as I have been telling, the Spark transformations will be done parallelly, whereas reading the data and iteration will be done sequentially. Okay, so first thing is creating the combiner. Let's focus on that one. Creating the combiner takes the syntax v comma 1, where v as your value, and assign the number 1 to your value, which we have been discussing from last 1 hour. So combiner will be created only when the key comes first time in the same partition. Take the example partition 1, k1 comma 12, k2 comma 13, k1 comma 11, k1 comma 16, k1 comma 12, k2 comma 13. If I say k1 comma 12, if I read it first time, perfect, it reads. Second time, it takes sorry, in the second in the same partition, second one is k2 comma 13, which is different. If I see here, yes, k1 comma 11 is repeated. When it is repeated here, it applies the second rule, which is accumulator. So this one you have to understand, you have to very clearly understand the syntax of your combine by key. As I have told you, creating the combiner, the first step, when the first step, it reads the key in the same partition and creates a combiner. And if the key in the same partition is repeated again, it applies a rule 2. Our rule 2 is nothing but your accumulator. Your accumulator will be having int comma int as your data type, and you are giving a value. Okay, this is the initialization. And for that one, accumulators, accumulator underscore 1 plus value, comma accumulator underscore 2 plus 1. Here what he means is, what is your accumulator? Your accumulator is 12 comma 1. Guys, simple thing. While initializing the combiner, v comma 1 means value. You are not concerned about key. So just park your group by key, reduce by key knowledge away now. That is little different, this is different. There we are working based on the keys. Here we are referencing with values. If you understand that logic, if you don't put things here and there, that will be very easy for you to understand. Earlier class, key, here value, because while creating the combiner, you are making the v as a reference value, your v as a value, and you are assigning 1 to it. Okay, so my k1 comma 12, okay, k1 comma 12 repeated first time. So when I created a combiner, I'm assigning a value comma 1, which is v comma 1. In the same way, when I read k2 comma 13, this is also first time, so I have given value 13 comma 1. I appreciate it. And as this is repeated here, k1 comma 11, because you have k1 here, you have k1 here. Okay, let's go back to step 1 again. Step 1 is nothing but create combiner. Create combiner, what it does is, if it has read the value first time, go ahead and assign value comma 1 for that particular key only. Okay, so creating combiners mean, for that key you are creating and you are assigning a value comma 1. If the same key is repeated, you have to add a second rule to it. That second rule is nothing but your accumulator, which is int comma int and value, and accumulator underscore 1 plus value, and accumulator underscore 2 plus 1. So here what will be your accumulator, which is 12 comma 1. Okay, and what will be your value? Your value will be your k1 comma 11. Okay, because it is the second time in the same partition k1 is repeated, so that's the reason why we have to use this logic. Okay, it is simple, very simple. Merge values mean, first time when the combiner is reading the value, you have assigned v comma 1. Okay, we are fine with it. What happens if the same key is repeated in the same partition? In that case, simply merge the values. Here merge the values means nothing but count the values. So my first thing is 12 comma 1, which becomes which becomes an accumulator, and 11 becomes a value. Okay, am I clear till this point? So this is my 12 comma 1 is my accumulator, and 11 is the value. Okay, k1 is repeated. Okay, now when I say accumulator minus 1 plus value, what is my accumulator underscore 1? I'm sorry guys, I used minus 1 there. It's accumulator underscore 1. Accumulator underscore 1 is 12, and what is my value, which is 11. What is 12 plus 2? 12 plus 11, 11 plus 11 is 22, 22 plus 1 is 23, yeah, which is 23. So it is 23 comma 1 or 23. Okay, it comes 23. So if you see here, I have jumped from this part I have explained here. When I say accumulator underscore 1 plus value and accumulator underscore 2 plus 1, so accumulator underscore 1 is 12, because this is my 12. This is my first part of accumulator, and the value is 11. So 12 plus 11 is 23. What is my accumulator 2? Accumulator 2 is 1, and when I am adding 1 to that one, which is 2, so I got 23 comma 2. Okay, this is the way how it works. Now k1 is done, let's go to k2. So k1 you have 23 k1 you have 23 comma 2. Okay, and if you see here, k1 is repeated again, which is 20, which is 12. Okay, so now what happens is, the newly created 23 comma 2 will be your accumulator, and 12 will be your value. Okay, so here this is my accumulator, this is my value, and accumulator of minus 1 is 23 plus value, which is 12, 35, and accumulator of minus 2 plus 1, accumulator of underscore 2, sorry, accumulator of underscore 2, which is 2 plus 1, 3. So what did I get? 35 comma 3. This way it continues throughout the partitions. So first you got 12 comma 1, and then you got final result as 26 comma 2. Okay, so next one, let's go ahead and do for the partition 2. If you see partition 2, K2, K2, okay, partition 2 you have, let's go one by one. We'll go with K1 comma 14, K1 comma 12. The first time K1 comma 14 came up, so it will be 14 comma 1. Perfect. And now K1 is repeated again here, so which will be 14 comma 1 comma 12. 14 plus 12, which is accumulator underscore 1 plus value, and accumulator underscore 2 plus 1. Okay, so that's how it works. So you will get how much, k1 k1 is 14, 12 plus 12, 24, 24 plus 2, 26, which is 26 comma 2. That's it, clear. Now we have done step 1, step 2 very clearly. We understood the logic. Now merging combiners is nothing but you have two accumulators, because you are working on a partition basis. For each partition, it gives one output, so that is one accumulator. And you have to define data type of your accumulators, as I've explained you earlier. Your accumulator 1 is int comma int, your accumulator 2 is int comma int, which is perfectly fine. Here what you're doing is you are summing up your accumulator underscore 1 and your accumulator 2 underscore 1. In the same way, you are summing up your accumulator underscore 2 and accumulator 2 second value. Okay, in that way, if you see here, what's the best way I can explain this one? It's nothing but 23 plus 26 and uh, 2 plus 2, because this 23 comma 2, okay, which is your 23 comma 2, which is your first which is your first partition output. Okay, and that will have to let me explain it more clearly. I think I'm confusing you guys here. Your accumulator 1 is 23 comma 2, that's what you have here. And your accumulator 2 is 26 comma 2, what you have here. Within the accumulator, you are asking accumulator 1 underscore 1, which is 23, and accumulator 2 1, which is 23 plus 26. Okay, here your accumulator 2 second, your accumulator 1's underscore 2 plus your accumulator 1 underscore 2. I'm sorry, this is my mistake, this is not 2 here, this is just this is spelling, this is typo, don't worry. Accumulator 1, accumulator first accumulator underscore 1 plus second accumulator underscore 1, which is 23 plus 26. Accumulators underscore 2 plus second accumulators underscore 2, which is 2 plus 2 4. So you have 49 plus 4, that is final value 49 plus 4. In this way you get the final count, and based on it you can take average by dividing the value with the number of time it has occurred. It's like 1 plus 2 plus 3 by 3, 4 plus 5 plus 6 by 3, like that. Okay, there is other step here which has to be the 49 by 4 by 2, because we have to count the average. That's what our example here is. That's how it works. So now let me go to next step where I have explained it more clearly. Yep, merge combiners is done, and partitioners, the last step. You have to count all the you have to count all the partitions and give them result. Okay, that's what it is. So you understood how to create a combiner, you understood how to merge the value, you understood how to merge the combiners and partitioners. I'll repeat this. Creating combiners mean for every read, for every scan, if it is the first time it's scanning the key, k1, for that key and its associated value, it creates a combiner value comma 1. If the same key is repeated again, in that case you have an accumulator and a value. For that, you need to count your accumulator with the value, and your accumulators underscore 2 will be added with 1. That is the second step if the key is repeated. Once that is done, you have to go ahead with the step 3, which is merging the combiners. When merging the combiners, each partition will have one combiner. So you have accumulator 1 and accumulator 2. So accumulator 1 will have underscore 1 and underscore 2. Accumulator 2 will also have underscore 1 and underscore 2. In that case, accumulator 1's underscore 1 should be counted with accumulators 2 underscore 1, and accumulators first accumulator underscore 2 must be counted with second accumulators underscore 2. That's it, and it will give the final result. This is the combine by key. If you want to get the average using combine by key, it just you divide all those values by number of partitions you have, it gives you the average result. And here comes the last one and the most confusing one, aggregate by key. Okay, so I hope you guys understood when to initialize 0, when to initialize dummy, when to initialize accumulator, when to count with element, when to count with value, when to count plus 1. So if you just go back to the recording, I think it should be fair enough to understand that logic. So next part is aggregate by key. uh, Once I complete this one, I'll also explain you how the comparison of different functions. Okay, so we have been working with combine by key, reduce by key, group by key, fold and fold by key. In this journey we have understood the initialization of 0 is not a problem, it will not affect your desired output at all. Okay, so we are going to do the same thing now. Aggregate by key also uses the required three parameters. The first parameter is a 0, which will not affect the total values of your collected, which is fine, I agree with this. In this phase, we are collecting the unique elements from the set. Then we can start with the empty set. Or if you are starting with the empty set dot Hadoop will be empty set of Hadoop, which means it will serialize or it will parallelize the data set across the cluster with an empty set if you are starting with it. Or if you add it also, it is nothing, it doesn't make any difference. So the combiner function, again, see, the combiner function has come again here. So let's recap that. The combiner function, which accepts two parameters, the second parameter will be merged into first parameter. The combiner function will work on local partitions only. The same function, nothing to worry. What we have learned earlier, we are just doing that here. Merge function works across the partitions. It also accepts two parameters. So here what happens is, the first thing, you are initializing a 0. I appreciate that. And the second value is, okay, let's understand the data set first. This is your partition 1, this is your partition 2, this is your key, this is your value. Okay, having said, initializing with 0 is not a problem. Okay, and now your accumulator is an integer and your value is a string. Okay, your accumulator is a integer and a value is string. Accumulator is not an integer here, I made a mistake, this is not int. Yep, as you're initializing with 0, it will be an int. It will be an int, yes. Accumulator is an int, value is a string. So, and on top of it, you are adding up your accumulator plus 1. And if you see here, accumulator int and accumulator int, which will be third part is merging the functions, because this partition will give you one function with this partition will give you one accumulator, and this partition will give you other accumulator. This one will be int, this one will be int. So you must be aware of the output of each level of your function. So in aggregate by key, you have three steps. The first step will be initialization, second step will be your combining, and your combined output of partitions should be of same data type. Okay, and here you are adding accumulator plus accumulator. Now this is the syntax. You have to understand it. Syntax you have to by heart it. Syntax you have to by heart it, but understanding how it works is important. Okay, so accumulator int and value is string. So the first is 0. So in the combiner stage at phase 2, we are avoiding the value part and only focus on key part. But in combined by key, we have avoided the key and value, we have assigned 1. When I say avoided is while creating the combiner, if the key is read first time, for that particular key value I'm giving one value. So that's what I meant to say here. Okay, so for example, as you're starting with 0, 0 plus 1 is 1. Okay, and then 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and that's how it is. Few, how many times it has occurred? Okay, this is accumulator. Your accumulator is 0. Okay, don't worry about this, guys. This is just a data type you are defining for accumulator. So first point is you are initializing a 0, and you are accumulating, you are counting your accumulator plus 1. So 0 plus 1 is 1. So first time few, if first time few has occurred, it will be 1. If it has occurred second time, it will be 1 plus 1. So 0 plus 1 is 1, which will be your new accumulator. So plus 1 is 2, which will be a new accumulator. 2 plus 1 is 3, which is a new accumulator. 3 plus 1 is a 4, which is new accumulator. So here what happened is foo is 4 times occurred, so it is 4, and bar has occurred 1 time, which is 1. We are not concerned about values here, we are only working on keys. So 4 comma 1 is your uh, value. Second time, if you see the partition 2, foo is 1 time, so it gives 0 plus 1. Bar is 1 time, 0 plus 1. Bar has occurred again, so 1 plus 1 is 2. So bar has occurred again, so 1 plus 1 is 3. So foo I got it again. So here foo will be 1 plus 1 2. So I have 3 bars and 2 foos, which is 2 comma 3. Perfect. So now your foo is 4 comma 1 2 comma 3. Perfect. Here what you're doing is you are adding the accumulators, which is nothing but 4 plus 2 6, 1 plus 3 is 4, 4 plus 2 is 6, 1 plus 3 is 4. The way you are counting the accumulators is your accumulators first value plus your accumulators second value, which is 4 plus 2 and 6 plus 4. That's it. Or I can also explain in a different way the partition level. This count the accumulators of this partition and count the accumulators of this partition. Simple. That's what the aggregate by key does. Aggregate by key is nothing but it has already got the map function implemented, which does the counting, and it aggregates based on the key, and then sums up and the once this implemented partition level. Okay, that's it. So now we have completed reduce by key, group by key, combine by key, aggregate by key, fold function, fold by key function. Now let's understand the difference between each function. Okay, functions comparison. You can replace group by key with reduce by key to improve the performance, which I have very clearly explained you the reason here. If you see here, reduce by key has already done a little map work and transformed reduced values to the worker node. In this way, the network and the movement of the data across network is reduced, increases the performance. Reduce by key performs map side combine, which can reduce network IO and shuffle size. That's explained. Group by key will not perform map side combine. That's explained. Combine by key is more general than aggregate by key. Okay, combine by key is very 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 important. Try to get more exposure on combine by key, because you can it's implemented in every phase. That's what I mean to say. Implementation of aggregate by key, reduce by key, and group by key is achieved by combine by key. That's important. Implementation of aggregate by key, reduce by key, group by key is achieved by combine by key. Aggregate by key is similar to reduce by key, but you can provide initial values when performing the aggregation. So here, aggregate by key is similar to reduce by key, but you can provide the initial values when performing aggregation. Did we start any initialization values or accumulators in reduce by key? No, we haven't. We just had uh, the tuples, and we just did tuple 1 comma tuple 2 and its summation, or we have just used underscore plus underscore asking it to sum the tuple values. We haven't used any initialization, but the core work and dependency is same. Combined by key is more flexible and general. You can specify whether you would like to perform map side. Okay. And then, however, combined by key is more complex and you would need to implement three functions. If you don't understand these three functions or these three important parameters in combined by key, your journey will be tough. If you understand these three, you can use combined by key wherever you want, whichever way you want. So sometimes you can also replace aggregate by key, reduce by key, group by key by just using combined by key. That's it. That's all the theoretical part of it. Now I'll try to explain you the practicals on how we can achieve this one. Give me 2 minutes. Let me go ahead and open my slides on the other laptop, which I can go through to explain how that works. Okay guys, hope I'm clear on the theory part of it. I have taken so much time. It's been more than an hour, I think so. That's fine. We are doing a very good and important thing, so I don't think it's a waste or something like that. So we are done now. We are going ahead with the practicals part of it. We have understood each and every transformation very carefully. Now we are going to apply each transformation at different phase and understand how the results will be manipulated. Okay, I'm starting the practical session. So the first thing we'll do is we'll try to understand the data set and accomplish the important functions implementation on that one. Okay. I'm opening Spark now. Spark shell master local. Sorry, syntax error. Sorry for that. Everything is explained here. I'll follow the same process. There is no wonders or magics I'm going to do. So the way I have used sc.parallelize or sc. This one, the same will be followed here as well. If you see here, the first we have used sc.parallelize. We have generated key pair RDD. So I'm following the same way here. My Scala is opened, which is good. So before that, I wanted to show you my data set. My data set is in MySQL-u. Okay. Okay, guys, we are going to apply our Spark transformations on these two tables, which are parent-child hierarchy tables. If you have some idea on the relational database management systems, our approach would be we are going to join these two tables, and once you join these two tables based on the common column what you have, but here I say common key. Okay, so once I join these two data sets, on those data sets I'll calculate the total revenue per day per customer. I have order ID, order date, order customer ID, order status in the orders table, and I have order ID, order ID, and order item product ID, quantity, subtotal, product price. When I want to, when I say total revenue per day per customer, this order item subtotal will give me the total revenue. And when I say total revenue per day, I have my order date here. Okay, so when I say per customer, it's depend upon the order customer ID. Is it order customer ID? Yeah, it's order. It's order customer ID. So what I have to do here, I want to get the total revenue. My revenue comes from this column, and I need per day from this column. Per day is date from this column, and I need per customer, which is per this column. So I have to join these two tables and then implement the logic on top of it. So when I wanted to get the maximum revenue customer, how do we get the maximum? Nothing but we just compare it the way we did for Smith, for chemist, for EC, CSC, for Rahul and the other guy, 1,200, like that. That's the comparison we need to do here. Now we'll do it in PySpark and Spark, both the ways, and show how the result works. This can be implemented at Python and also Scala as well. There's no big difference. It's just val RDD and that difference. If you are using Scala, it's an RDD. If you are using Python, it's just defining it. Okay, so let me go ahead and read my data. I'll first read orders data, which is orders text file, which is users cloudera scoop underscore import and orders. I'll check my data first for I in orders dot take off 5 values from that one, and then I'll print of I. Okay, so it has taken the values correctly. That's okay. I have just read 5 values. That's why it's showing like that. Now let me take order items. Order items equal to sc dot text file. In that I have my file over here. I have already imported this MySQL data into my HDFS using ITversity playlist for the scoop operation. So you can refer that. Scoop underscore import. Where is my order underscore items? Perfect. For I in order items dot take off I print of I. Perfect. So my order items are my orders RDD is fed. Order items RDD is also fed. Now for me to join these two tables, I have to use the common column and split the data based on that. Earlier, if it is a key value pair, it starts with 0, 1, 2. The first value will start with 0. Okay, let me explain that here for you. In here, this is 0, this is 1, this is 2. Sorry, this is 0, this complete is 1. Okay, because it's date. This is 2, this is 3, because this is an RDD. It's not a tuple. If it's a tuple which comes with -1, I'll just tell you that in next 2 minutes. Okay, now I have my orders and order items read correctly, and I need to filter this data as it is comma separated values. I have to isolate the order ID, or I have order e. Let me come back. Let me come back. In here, it is order ID, which is 0th column, and here it is first column. Don't get confused with this one and this one like I did earlier, because order ID and order ID are parent and child tables, not order item ID, which is just 1 2 3 4 5 6 7 8 9 like that. Okay, so order ID and order ID are the parent and child relationship entity. So from this table, I have to split this one as the key and the entire record as a value. In the same way, this one should be my key and the entire record should be a value. So as this key and this key are same, I can join the data like the way I have done for, come back, as the way I have done here. So if you see here, you have if you see here, where is that? If you see here, you have first k1 and k1, and then you have counted all the k1s. So this key is same, this key is same, and you have used you have added them in the same way. I'm not adding here, but I'm just joining the, I'm just making a common uh, data from that one. Okay, now for me to do that, I have to split the data. I will define that one as orders key value, because I'm from the comma separated data set. I'm going to create a key value now. Order, let's make orders key value. This key value you are applying on orders dot map function. and once you apply your map function, you will have to tell, as you are using PySpark, there's a function called lambda. So I'm not going to spend time on lambda functions. You'll have to go and Google it. It's very simple and straightforward. So on top of orders function, I have applied lambda function. So here I'm going to initialize a rec, and the rec will be an int as I know it already. So int rec dot split with comma separated value, and my I'm going to split with 0, which is order ID, and then next thing my record will be the entire key. Okay, I'll explain you this one what I'm going to do here. This is okay, int rec dot split comma separated with 0. As this is a key value pair, I need to give this one as a key and rec as a value. How many brackets were open here? 1, 2, 3. How many were closed? And I need to put one more. Okay, perfect. Guys, this one is simple, very, very simple. Your record is a comma separated. Okay, I am initializing a lambda function. In that lambda function, I'm telling a record. In that record, my typecast is integer because this is all int. Okay, and when I'm going to split with the here I'm going to split with this one, which is an int. That is the reason why I have mentioned int. And here I am asking rec to split with a comma separated value. In that, take the 0 value. Which is 0 value? This is 0 value, which will be the key, and the value will be complete record. So what happens here is this one comes on your left side and the complete record comes on the right side. Let me show you that. For I in orders key value dot take of 5. Okay, see, this is your order ID, which is a key, and this is a tuple. Now we understood what is a tuple, right? Because tuple will be a combination of values, or it can be a different record which is associated with a key. Okay, so this is fine. This is, you got your output now, and you have filtered the data based on your order ID as a key and rest of the things as values. Perfect. Let me go ahead and do for the order items now. So for order items, I'll do order items key, order item key values. I just wanted to make sure the notation is correct because this is fine, no problem. I'll do Control C and come to there. Yeah. No live node contain current block locations, data node, info storage. This is fine, no problem. That's fine. So this is for your orders. Now order item key values equal to order items RDD. It's not RDD, it's a it's a PySpark. So you have a map function on top of it, and you implement a lambda algorithm and rec. You also know it's an int here, so you give int, and once you give int, we have to do a rec dot split function, which is the first column, which is fine, and which will be complete record. The same way how I did earlier. The same way how I did earlier, but earlier I have split with 0. This time I have split with 1. If you ask me the reason why, here this is the order ID, this is the order item order ID, which is the parent child relationship. So I can join my data sets using the common column. So that's what I'm using here. Okay, so let me check that. For in order item key values dot take of 5 print of I. Perfect. See, I have got my order item already as a key and a value as a tuple. Okay, so now I want to join these two data sets. Joining is very simple. Let me go ahead and do that. Joined data equal to order item key values dot join orders. Orders or order? Let me check. Let me check. Orders. It is orders key value. Okay. Orders key value. Perfect. That's very nice. For in, always check the results before you do the next operation. Join data dot take of 5. Why is it jumping like this? Sorry guys, there seems to be some interruption. This should be okay. Control C. For in joined data dot take of 5 print of I. It will take some time because it's gonna join the data sets and give the results. There are some best practices on the way you join the data. I'm not going to discuss that now. See, this is your order item and this is your orders. Okay, if you see something interesting, this is 2, this is 2, sorry, this is 2, this 2, and this 2, this is 2, this is 2, this is 2, which means it's joined based on the order item. Okay, now very important part, this one is key and this one is value. When you're talking about tuples, this one is 0. Okay, this entire record is 1. In that, this one will be 1 of 0, this one will be 1 of 1. If you ask me why, that's way the tuple works. Okay, it's not a key and a value pair. It's you have joined two data sets here. When you join two data sets, okay, when you join two data sets here, it has given different values or element of values which is categorized as tuple. So this will be 0, this will be 1, entire set will be 1. In that you have this one as 1 of 0 and this one as 1 of 1. So let me come back to my problem description, which is I want total revenue per customer per date. Which is the one that is giving me total revenue? Which is this one, 299.95, 49.98, and 1 second, let me cross check that, which is fourth one. Okay, 0 1 2 0 1 2 3 fourth one. Okay, so when I wanted to get, why is this opening? I'm sorry. So 0 1 2 3 4. When I want to read this one, I will ask Spark to split. My dear Spark, take the record or take the tuple 1 of 0 and split with comma separated for the fourth value, which is this one, because 0 1 2 3 4. Okay, this is for the order item subtotal, which gives me revenue. And I want per date. Where do I have date? I have date in the orders. Orders is this one. In this is 1 of 0, this is 1 of 1. So 0 comma 1. So my dear Spark, take 1 of 0 and split the records for 1. Done. So you have got your customer, you have got your revenue, you have got your date. I'm just explaining how we are splitting the data. And now you want per customer, which is customer ID, which one is customer ID? Customer ID is this one, 012. Okay, so in here it will be from orders table, sorry, from orders table, third column. So my orders table is this one. So 1 of 1, in 1 of 1, this is my order ID. Okay, that's how I can split the data. Now let me do one by one. So here you have your order ID. In that order ID, you have all columns from order item key values and order item key values and order key values, which is perfect. Now I'm going to take the data per date and per customer. Okay, orders per date per customer, per date per customer, spelling mistake. Where are you applying this transformation? On join data, which is join data dot map function. On top of it you have lambda function. So here you'll have a rec function. You are initializing the rec, and as I know, I need to give the double thing. Yeah, it's a double quote, because we'll have two braces closed. One will be record and other one will be combination of record. So the first thing is rec of 1, because this is 0 guys, this is 1 entire set. In that 1 of 1, which is this one, in this one I need a date is 0 1. Okay, so in this one I'm going to split with comma separated as 1, as I'm getting per date per customer. So this is my first key. Okay, and after that rec, I need 1 of 1 again, which is 1 bracket close dot split comma. So you got your date and you are your customer, you need customer ID, which is customer ID, come back here, which is third one, right? Order date is fine, customer ID is third one, 012. Okay, so here which will be 2. This is perfectly all right, and I'm closing this one as a how many brackets do I have to close here? It is 1. Perfect. So this is my key, and my value will be float, because I need order, I need revenue here. So revenue can be taken from float. On top of it I have a rec function, I need to implement it because that's my record. Or I can say rec 1 of 0, and which one is the value here? Split function 0 1 2 3, fourth value, which is 4, and close a bracket here. So I have opened 2 here, 3 here, so 2. Should be okay. Perfect, it has taken it correctly. And now let me read it. Guys, I'm explaining you once again. Rec 1 of 1 is nothing but this completely, this complete set is 1. Okay, when it is 1, this one is 1 of 0, this one is 1 of 1. From 1 of 1 you're asking Spark to split the first value. So this is 0, this is 1, so this complete set is here. And in rec 1 of 1 you're splitting 2, you're splitting 1, you got it. 2 is nothing but customer ID. Perfect. Now this is your key, and your value will be your revenue. Revenue is in 1 of 0, which is 0, 1, 2, 3, 4. So you have your key, you have your value. Now let's see the result. For I in orders per date per customer equal to, sorry, for I in dot take of 5 print of I. Sorry, spelling mistake. Per date. See, you have your date, you have your customer ID, you have your revenue generated. So your first part is the necessary information for your first part is achieved. Okay, so the first thing what we need to do here is amount collected per day per customer, which means now you got orders per date per customer, which you need to correlate with the amount per day per customer. Okay, I'll explain the logic here, don't worry, I'll explain the logic. Sorry guys. Amount collected per date per customer, this is fine. I'm applying this transformation on. When this occurs I have to do a control C, come back again. Amount collected per date per customer is equal to orders per date per customer dot map function. Now you're applying map function on it, so you need to understand this one is 0 and this one is 1. So the way we need to get that one is you need to isolate the revenue, or you need to isolate the date, and we need to isolate the date as amount collected per date per customer. So your date will be a key and your customer ID and revenue will be the values. Let's do that now. Or before implementing that, we can implement a reduce by key function to count the values for each key, or for each amount collected per date. Okay, so day will be my key, and for each day I want it to count it. Let me use a reduce by key function, which is very easy. Reduce by key. What is the syntax for reduce by key? We have how can I define that? I will define it as accumulator, not accumulator. That's fine. Accumulator. I don't want to use accumulator term. I need to use something else. I'll use sum and amount, which will be like sum plus amount, which is nothing but you have you are using reduce by key function, and you have here you have your sum and amount. You are asking your Spark function to go ahead and add for that particular day, get me the sum. And I mean, sum and amount is nothing but I'm just I can also use value or something like that, but I'm just using the easy way to do it. And let's see how that goes. This syntax error, which is lambda function is missing because it's a PySpark. I have to mention the lambda function. Is everything all right? Let me check once again. Spelling mistakes, anything? By key is fine, and then sum is fine, and then amount is fine. Brackets is line closed. Yes, perfect. Now for in, amount collected per date per customer. Amount collected per date per customer dot take of 5. In that I have print of I. It's taking time because it has to do the count. Please don't kill my cluster. Yeah, it's okay, it's doing it. It's fine. See, now it has given the date, it has given the order ID, and it has given the total revenue for that date. Okay, makes sense? Did you understand how the reduce by key has worked? Let me show the value here. Let's compare that one. Here it's for same date. Okay, if you see here 2507 2507, for same date it has got, for same date for different customers it has got different revenue. Now for each date I wanted to get the aggregated revenue, which is the output here. So if you see here for 1818, though it has come, the customer ID is different. Okay, if you see here, customer ID is same and the date is also same. I am just filtering my data in such a way for each customer distinctly, for each day distinctly, what is the total revenue generated. Okay, I'm halfway through now. Hope you understood how the transformation has worked. Okay, now let's go ahead, and here what I would do is I want to isolate my date as a whole, date as key, and customer ID and revenue as a values. If you ask me why am I doing that, it will be simply easy for you to calculate revenue per date per customer. Okay, let me go ahead and do that. Revenue per date per customer equal to what's our earlier distribute RDD, amount collected per date, amount collected per day per customer. On top of it I'm applying lambda function and lambda. It's just a split. You're splitting your date as a key, and you are splitting your date as a key, and then why is the cluster breaking like this? This is irritating. Let me come back. That's fine. Okay, I'm back there. So lambda function, and in my lambda function I have to define split. So I will mention it as rec. In the rec I have rec 0 of 0, because if you see here guys, this is completely, I'll explain that. This is 0, right? And this is 1, right? In that, this is 0 of 0, right? And this is 0 of 1, right? Now I want 0 of 0 as my key, and 0 of 1 comma 1 as my value. That's what I'm going to do. Rec 0 comma 0, is that correct? Or yeah, it should be okay. Lambda rec 0 of 0, which is key, perfect. And the value should be rec 0 of 1, which is 0 of 1 is nothing but your customer ID, comma rec of 1. How many brackets did I open here? 1 2 1 2 3 1 2 3. Invalid syntax. Something is wrong. Sorry, there's a spelling mistake, guys. Sorry for that. There's a syntax error. Like 0 of 0. Amount collected per day per customer is not defined. Is there a spelling mistake? Let me check that. What's the value? I think amount collected per date per customer. A C is uppercase P. Amount collected amount collected per day per customer. It's correct only. Why is it saying problem? Let me see if it is. No, I'm sorry. Why am I using RDD here? This is PySpark. Amount collected per day per customer dot map. Give me 1 minute, guys. I'm pausing the video because I wanted to fix this and come back. Bear with me. I don't know what the problem is.